Hello, welcome to the podcast of Wageningen Alternative Protein Project, where people talk about their work in protein transition. I am Shan, a master's student in food technology, and I will be your host today. Silvia Snel is our guest today, who is a PhD student. Her project is a cooperation between Wageningen University and University of Applied Sciences, Western Switzerland. Hello, Silvia. I'm so glad that you could be here with us. How are you?
Yeah, I'm good. Thank you for inviting me for this interview. How are you?
Yeah, I'm great. The weather is not that great, but then I guess now you're sitting in Switzerland, right?
I am, yes.
Yeah, this is the first time we interview someone who's currently out of Wageningen or in the Netherlands in general. So how is it there? Do you miss home or anything?
Yeah, it's nice here. I mean, I'm in the middle of the mountains, so a lot of skiing opportunities and hiking in the weekend, so that's really nice. But yeah, of course, I also miss the Netherlands and Wageningen, especially. Yeah, but it has its advantages here to be here as well.
Yeah, I guess the nature there is with a lot more variety than it is in the Netherlands.
Yeah, also I'm like in a really small town, so I'm really in the nature, I feel.
Oh, that's nice.
Yeah.
So tell us a little bit about yourself.
Yeah, so I'm Silvia. I'm from the Netherlands originally. I studied food technology at Wageningen University. And then for my thesis, I worked on the juiciness of meat analogues, which was like part of the consortium Plant Meat Matters.
Mm-hmm.
And there I think I really got excited about meat analogues and the production of them.
Mm-hmm.
So then I went to do an internship in Chile in South America.
Wow.
For a startup that wanted to produce vegan meat alternatives.
Mm-hmm.
And then I liked it there so much that I stayed working there after my internship for about 1 year.
That's so cool.
Yeah, it was actually really nice because we developed like a hamburger, and now it's there in the Burger King. So if you go to Chile, you can eat my product.
Wow, that's so cool.
Yeah. Yes, that was really nice. Yeah, but then I started missing really the research side of of production. So then I went looking for a PhD, and I contacted Adsian in Wageningen, and he was starting a project together with Michael Beider, who is a professor here in the school in Sion, the School of Applied Sciences in Switzerland. And they were starting a project on high moisture extrusion cooking with a new cooling dye, so to make different and better kind of textures. And yeah, so I got in contact with Michael, and then I decided to do a PhD with him. So now I'm here.
What is the title of your PhD study?
Yeah, it's called Improving the Structure and Flavor of Meat Analogues. So I'm working together with Klextrol, which is a company for extruders. So they make really the machines. And I'm working together with Firmenich, which is a flavor company. And they help me with the flavor side of my project. So I'm working here with high moisture extrusion cooking to make meat analogues. But now, we developed a new dye in-house that allows us to have better control of the texture of the final meat analogues, and also gives us larger size pieces. So they're thicker, but also larger. And this can help us if we want to design like whole cut foods, because this is something that's really lacking right now.
Yeah.
And in this process of high moisture extrusion, which is I think the most common one for producing meat replacers, one of the tricky things is adding a flavor. Because during processing, almost 80% of the flavor is often lost. So the end product has a really soft flavor, or maybe not at all a flavor anymore. And flavors are, of course, quite expensive to add. So this is really, something that, a bit problematic. And therefore, I want to see if I can protect the flavor compounds somehow so that they don't get lost during processing.
So the reason that the flavor get lost during processing is because of the heat in the extruder?
Well, no, actually, this is only part of the reason, because the flavor binds to the protein through hydrophobic binding.
Mm-hmm.
And this binding is quite, the affinity for binding of these flavor molecules, it depends a bit on the type of molecule.
Mm-hmm.
But for example, sulfur containing flavor compounds, which are important if you want to have like a savory taste, they bind quite strongly. So in that case, even if you don't process, if you only mix the protein with the flavor, it already has a strong binding.
Mm-hmm.
So in a way, the process also influences the binding, it increases it, but it's not only processing.
So different protein has different affinity to the flavors. So then I guess balancing the flavor would also be kind of tricky because you're dealing with a mixture of all different kinds of proteins and other compounds.
Yeah, exactly. And also, if you have like a perfect flavor, perfect meat flavor, then it can happen that part of these molecules that are in this flavor mix bind really strongly, and then the end flavor is really different from what you tasted like in the lab. So yeah, so this can be a problem.
I actually wasn't aware that you need to add the flavor during the extrusion. I always see these two aspects like two different ways. I guess I always assume that the flavor will just stay with it unless it gets decomposed by heat, but I guess it's not because the protein reacts differently to it.
Yeah, I mean, you can also add it after production, so or after extrusion, which you also see a lot, and they have like kind of this marinade. It's oil with flavor and spices.
Mm-hmm.
But then, if you really want to have the flavor in the product itself, this is difficult to do after processing. You can only coat, so to say, the outside.
What you're currently researching on is actually how to design this whole process, starting from the ingredient up to the final product of the extruder, so that it comes out as a nice vegetarian meat product, right?
Yeah, exactly. Like I'm looking at the same time on process, so how to improve the process and get better textures.
Mm-hmm.
But also with the flavor to protect it in a way, or also even to understand better how we can prevent this binding of the flavor to the protein, so that we have better tasting meat analogues in the end.
I see. So apart from what you just mentioned about the flavor, what is actually making whole cut meat analog so challenging through extrusion?
Yeah, the challenging thing about extrusion is that normally you need to have a long cooling die, because during extrusion you heat up the protein mixture quite a lot until 145 degrees often.
Mm-hmm.
And then you have to cool it down before it flows out.
Mm-hmm.
And during this cooling, it's often believed that you make the structure of the meat in this cooling die.
Mm-hmm.
And these cooling dies, they cannot have really high thickness, because if it's too big, then you don't have enough cooling. So your product that comes out is quite small and thin. And then you have different size of extruders. So if you go to really high, like a production scale, then still you can have like large pieces, but you can never achieve really like a steak or something, because it's too big to have a stable process.
I will imagine that if you just make the cooling die longer, then you'll be able to cool down the product, even though the product might be bigger. But maybe there's also the problem with heat transfer. When the thickness is bigger, then the heat is not so well dispersed overall in the product, and then the product will not turn out so good, I guess.
Yeah, that's exactly. It's a very good guess of you, because that's exactly the problem. You can make the cooling die longer, of course,
Yeah.
but then the sides will cool down and get stuck in the die, and the middle will stay quite hot and just flow out. So you don't get like a nice product outside.
Sounds like a big challenge.
Yeah, but it's interesting because this process, extrusion cooking, has been used for meat replaces already since the 70s, I think.
Mm-hmm.
And still we're using quite the same setup and the same kind of cooling dies. So it's interesting also to think like, okay, we didn't improve the process until now that much. So maybe we should look again at the process itself and see if we can improve it. Because until now, most people focus on the ingredients and the composition of different ingredients, but not really on cooling dies, for example.
This reminds me of the other interview I did with another PhD in FPE, Ninka Coleman.
Yeah.
So she's also working on extrusion, but she's focusing on the understanding of what's happening inside of the extruder.
Yeah.
Yeah, then these are the two very nice, I guess, angles to study the extruder nowadays. So even though we have been using this equipment for decades, but still up to this point, we still don't, firstly, we don't really understand what's happening. Secondly, there isn't so much evolutionary improvement on the technology, I guess.
Yeah, it's so interesting. It's nice to hear that Nienke is working on that, because yeah, we don't really know what happens during extrusion and why it works actually. And maybe if we understand how it works, we can develop a whole new kind of process that is specifically for meat analogues. Yeah, because actually it was like extrusion was not designed to make meat analog, it just happened to work. So interesting.
But I do get it that because if you want to really look inside the extruder, then the temperature and the pressure would change. Then what you're looking at is not really what's happening inside of it. So that's making it really difficult to have a picture on what's happening.
Yeah, it's very complex. Yeah, and it's really hard also to try to replicate the process in a different way. Yeah, you really need the extruder to be able to study it, but then you can only really look at the beginning and the end because of this high pressure and temperature.
Mm-hmm. Since there's this size limitation for the cooling die, then do the industrial extruder have the same size as the ones we use in the lab?
For example, I'm using an extruder here, which is pilot scale, and it has like a throughput of, like 20 kilograms per hour.
Uh-huh.
But in really production lines, it's often like 300 kilograms per hour. So it's a lot bigger. And then, if your machine is bigger, your die also can be larger, so you can have larger products also.
But this larger product, you probably mean throughput instead of the actual size of each piece of the product, right?
No, also the size, because your whole production just in dimension increases. So the throughput is higher, which means your extruder barrel is larger, and this means your cooling die can also be larger. And so you increase a bit the size of your products.
But then wouldn't it make the heat transfer problem a problem if the cooling die is actually larger? Because then the surface area in relation to the volume is probably smaller if the whole thing is just bigger.
Yeah, so they are still limited to, it depends a bit, but I think normally the thickness is around 1 centimeter. So, and they have cooling from all sides, so all around. And then you can still achieve enough cooling.
Uh-huh.
But if you want something thicker, then it becomes a problem.
Ah, okay. Okay, that makes sense. About the flavor, so the plant protein itself, they will have this, we call it off flavor compounds already there. Then do you also look into how to decouple them from the protein?
Yes, so yeah, a lot of these pulses have a beanie flavor.
Yeah.
But actually, the nice thing about extrusion is that it decreases the beanie flavor. So during this like high temperature, high pressure, we lose a bit of this off flavor. But yeah, I just noticed because it was studied before me, but I'm not working on the off flavors myself. I'm more working on adding flavors.
Do you think that the texture and flavor go hand in hand? Because normally, like when I think about texture and flavor, we think about them as if they're two independent aspects of a food material. What's your insight for that?
Yeah, no, I definitely think they are related because if you take, for example, juiciness, often like if you have something really juicy and the flavor comes out in this juice, then you maybe like it more. But how juicy something is related to the texture. Because if you have a very spongy texture, for example, then a lot of juice can come out when you eat it.
Mm-hmm.
So I think these things are definitely related. Also, if you have a texture that reminds you of something, then sometimes you immediately already like taste this. I think that's very interesting about sensory.
I'm really curious that, so in the lab, do you actually taste the product that you try out after it's extruded or not really?
Yeah, I do. It's like they always make a bit fun of me because I want to try like my own product. But yeah, I like to try it, and often it's quite nice actually. Yeah, sometimes we get really nice flavors, like a chicken flavor or something,
Mm-hmm.
and yeah, it's not bad.
But then I guess when you collect the data from the flavor, you probably don't just go around and ask people to do sensory evaluation of it. Instead, you probably use scientific method for it.
Yes, so we use GCMS to detect the flavors.
Uh-huh.
But we can also do some sensory analysis together with Firmenich.
Mm-hmm.
But then you really need a trained panel, and this takes time. But those results are very interesting as well because people are just more sensitive to little changes, I think.
Mm-hmm.
And also what you already said, like this relation between the structure and the flavor has a big influence. So our GCMS cannot detect that. It only detects the flavor molecules that get out. So yeah, this is very interesting.
I think your research project is especially interesting because it combines both of these aspects, like texture and flavor. I feel like, I guess for most research projects, there's still, in a way, independent aspects. So I think it's really interesting.
Yeah, I think so too. Yeah, I'm really excited about it because I think consumers are really open to try new kind of meat replacers and are open to replace meat in their diet.
Mm-hmm.
But we have to improve them a bit, I think, because if they try it once and they don't like it, then the chance that they will try it again is really low.
Yeah, definitely. First impressions is very important.
Yeah, exactly.
So after hearing about your project, would you also like to introduce to us what kind of research is generally done in the chair group where your project is located?
So I'm connected to food process engineering in Wageningen, and there they do a lot of research on different processing methods and also ingredients. So how to extract ingredients in different way and their functionality, the differences between different proteins. That's really interesting. And here in Switzerland, we're working a lot with extrusion. So not only for meat replacers, what I am doing, but also, for example, to use it for cheese analogues. So yeah, we are sort of working with extrusion to make new products of plant proteins.
That's super nice. So the department you're working in Switzerland is also kind of focusing on the alternative protein, let's say.
Yeah, exactly. Yeah.
That's nice to know.
Yeah.
What do you think is the most important knowledge or skill set for researching in the topic of yours?
That's a good question. I think what is important is that you're creative, I think.
Uh-huh.
And also, I think you have to be just really motivated and not give up. Because, yeah, it can take a while until you get some nice results. And yeah, I think the most important is just that you're motivated, and all the rest you can learn. I think so.
Then people should really follow their passion, I guess.
Yeah, no, I think that's really important, because otherwise, yeah, if you're really passionate about something, then you want it to succeed, you know. So yeah, this is a big driver for me, at least.
So the other people I interviewed, everybody said the same thing about passion.
Yeah. Interesting. Yeah, I think it's important if you do a PhD that you're really passionate about your topic.
Yeah, because it's not an easy work, right? Like a lot of challenges every day and a lot of setbacks maybe at times.
Yeah, and it's not something, I mean, you spend normally 4 years on it. So if you're only slightly interested in your topic, then I think after 1 year you will be completely done with it. Because
Yeah, totally.
yeah.
Yes, that's very true.
Yeah.
What is your view of alternative protein and its future development?
Yeah, I think it's really an important research topic, and I think it will be only more and more important towards the future, because I think, yeah, a lot of consumers also realize this already, but at some point I think we have to really replace, yeah, animal protein for a part at least with plant protein, and we can help consumers make this switch by producing tasty and nice products for them. And yeah, you can see that also big companies already see this trend, because there's a lot of big companies now producing, for example, meat replacers like Unilever. Yeah, I think this will only become more, actually.
So, do you personally have any hobbies related to the transition of protein? Or does your research in this field influence your lifestyle in any way?
I mean, I am vegan myself, but
Oh,
I have been a vegan since already 4 years, I think. And before that, I was already vegetarian. So this didn't change because of my research.
uh-huh.
But it does make me, of course, yeah, very passionate about this. And
Mhm.
I think as a hobby, I really like to cook and bake. And often I try to take a dish that is very, yeah, known or very typical for culture reasons, but with meat. And then I try to like make something similar but vegan.
Oh, that's super nice.
Yeah. Yeah, so for example, last weekend, I don't know how much you know about Dutch sweets, but there's this thing called mergpijpje.
Oh, I know it.
You know it?
Yes,
Yeah.
I've tried it. It's very sweet for me,
Yeah, it's
but
very
it's nice.
sweet, but it's so good, and it's like it was my favorite as a child. So I really wanted it, but there's no vegan option for it. So I just, yeah, took the sort of the recipe apart and tried to make everything vegan.
Mhm.
So, and then I succeeded. So I had like my own vegan mergpijpjes last weekend,
Oh,
and they were really good.
so nice. I would love to try it if that's possible, but yeah,
Yeah.
you're in
Well,
Switzerland,
if
so
we meet, then I will make you some.
that's nice. So how what did you substitute for the cream inside? I assume there's cream in it.
Yeah, I made sort of a vegan buttercream, and this is just, instead of butter, you just use a vegan butter replacer.
Oh,
And I added some like vanilla to make it a bit more tasty.
that's that's super interesting. I should do something similar because I'm Chinese and a lot of, at least for me, a lot of the serious Chinese cuisines are loaded with meat.
Yes.
And yeah, I'll go think about whether I can make something vegetarian out of it.
Yeah, that would be nice. And then share it, please, with me, because I love Chinese food.
Yeah, I would love to.
Yeah, there are quite some people like not chefs, but just people like you and me who make their own recipes for Asian dishes.
Mm-hmm.
I think I've also seen this for Chinese dishes, and I tried them. It's really, really good, always. So I can recommend you some.
Yeah. I would really appreciate it. Please send me some links.
Yeah, I will.
Anything you want to tell the fellow students in Wageningen interested in the field of alternative protein?
Yeah, I mean, if you're interested in it, definitely try to do a thesis in this kind of topic. I would really like to have some student from Wageningen do a thesis with me, but right now with the COVID situation, it's a bit complicated because, if you want to do a thesis with me, you would have to come to Switzerland and stay here for the duration of the thesis. But right now, from Wageningen, this is not allowed. So that's very unfortunate. But yeah, maybe for future master students, they can come to do a project with me.
Yeah, or maybe in a few months the situation is gonna be better. And
yeah, I hope so. I really hope so. But it also depends on the university, of course, what they advise. And so I hope really that I can have some thesis student from Wageningen next school year. But we'll see how it goes.
Finger crossed.
Yeah. Yes.
Any fun activities you can think of that a student association like us can do to boost the awareness of alternative protein on campus?
Fun activities. Well, yeah, and like I already said, I just really like cooking and baking. So I would always be in for an activity that involves something like that. So, or you could do like even like a vegan barbecue. I think a lot of people would be surprised how good that can be. Or vegan high tea. But I'm just thinking about food now, so I don't know.
I can see that you're.
Yeah. I don't know if these are really good ideas, but
no, I think they're great ideas. It's just that now it's a bit hard to implement it.
Because of the situation, yeah.
Like a vegetarian recipe development competition, I think, like what you do in your spare time.
Great, yeah.
That could be really cool.
And I would like to be in the in the judge panel.
We'll definitely invite you.
Thanks. Yeah. Or a bake-off, a vegan bake-off.
Yeah.
But then you really need to be able to see to be able to meet with each other, because otherwise it will not be fun.
True. Or I guess in Corona time, maybe we can still do like photo competition for the dishes you made.
Yeah, that's nice. Who makes the most pretty cake?
Yeah. It's super fun talking to you about your research and about a bit of your life in Switzerland right now. And we're super happy that you agreed to do this interview with us. And in the future, maybe there's going to be another opportunity for us to follow up with your PhD project.
Yeah, thank you. For me, it was also fun to talk about this. And we definitely stay connected. And if someone is interested in what I'm doing here, they can always just send me an email. And I'm more than happy to answer any questions. So
That's super nice of you. Thank you so much for being here with us today.
Thank you for inviting me.
Thank you for listening. If you have enjoyed it and would like to hear more interesting interviews about alternative protein, subscribe and follow our Facebook page of the Wageningen Alternative Protein Project. Thanks again, and we will see you in the next episode.